All right, I got a question today and a few minutes ago, and I just decided to make a quick video on it. So, a singular matrix. What is a singular matrix? It's one where the determinant is equal to 0. So, first, what's this determinant? If we have a matrix A, if A is equal to W, X, Y, Z, right? Then the determinant of that matrix can be calculated by taking the product of this lead diagonal. So we're going to take W times X. So the determinant of A is going to be calculated as W times Z, minus product of the non-leading diagonal right here. And that's going to be X times Y. So if A is singular, right, we have that, we can say that W times Z minus X times Y is equal to 0. Why would you need this? Because you can use this to apply to solving an equation, and I will make another quick video on that. All right, so I'm just throwing in some quick examples for the singular matrix that I explained. This question says, now these questions can be worded in different ways and they come back to the same thing. Determine the value of X for which 3X on 1, 4 is singular. Remember we said when it's singular, the determinant is equal to 0. So we're going to look at this. We're looking at multiplying product of the leading minus the product of the non-leading. So we have what? 3 times 4 minus 1 times X is equal to 0, right? So 3 4s are 12 minus X is equal to 0. So people solve, equations in different ways. I say you can transpose the X and do the opposite of subtraction, which is addition, or we can add X to both sides. Doesn't really matter. We're going to get the same thing anyway. So we have right here, these cancel. So we have 12 is equal to X. All right. Another way. Given that M is equal to 2X, 4, 9, 1, calculate the values of X for which the determinant of M, so this is another way that we can write the determinant of M is equal to 0. So let's go again. So we have 2X times 1 minus 4 times 9. No, I did note is equal to 0. I did notice that first up here I did 1 multiplied by X, and down here I did 4 times 9. Doesn't really matter. The idea is that we're multiplying these two and these two. All right, so we have here 2X minus 9 4s are what, 36, equal to 0. And we can add 36 to both sides, or transpose the 36, take it over and do the opposite, whichever way you want to describe it. I'm going to just do it the other way now. And we have 2X is equal to 36. So X divide by 2. So we can transpose the 2 and divide because we were multiplying on the left. We're going to do the opposite. 36 over 2, which is 18. All right. And then another way that this question can occur is the matrix P is defined as 7, 2, negative 1, M. Determine the value of M for which the matrix, oh, this should be a P. Oh, well, my bad. P does not have an inverse. So when would it not have an inverse? When the determinant, this means that therefore the determinant is equal to 0. Because if the determinant is 0, remember now, I haven't spoken about that, but for the inverse of a matrix, it's 1 over the determinant times multiplied by the rearranged matrix, right? If this is 0, 0 times anything is 0. So we're not going to have an inverse. So let's work this out. So we have 7 times M minus 2 times negative 1. I try to keep the negative numbers in brackets. That way, you know, we don't have signs just falling off the bus. So we have 7m. Negative 2 times negative 1, positive 2 equals 0. We can transpose the 2, 7m is equal to negative 2. When you transpose, you do the opposite. And so we divide throughout by 7, or transpose the 7 and do the opposite of multiplying here, which is dividing. So m is going to be negative 2 over 7. So if we replace negative 2 over 7 here, we get a determinant of 0, and therefore we have no inverse. And yeah, that's 3 ways in which we can be asked to solve a question the same way.